Hello and welcome to the podcast about triangle congruence theorems. Um, I'm going to talk about really what the congruence theorems are real quick and how we talk about triangles being congruent, and then I'm going to show you my Geogebra app like this one that has each triangle. I'm not going to say congruence theorems. I'm going to say triangle parts combination, like a three-part combination that we can make based off a triangle. We're going to use these tools here to investigate if these combinations can force two triangles to be congruent, okay? And then we have the HL theorem here that after we talk about these, I'll get to the HL theorem to explain what that one means. Okay, so basically triangle congruence here. We have two triangles. They look congruent, right? We talk about transformations. I can rotate this triangle to get it in the same orientation as this other one that I want to show are congruent. And then I could really just translate it, right? Slide this guy over. Didn't rotate enough. But the point of this is these are two congruent triangles, right? It doesn't matter their orientation, even if I reflect this thing, which is flipping. So I'm going to flip this, say, maybe this way. Notice orientation, it's different, but we understand that these two triangles themselves are actually congruent. So to show it, to prove it mathematically, what we have to do is we have to know for a fact that the triangle's six parts, and what I mean by the six parts are like the three sides, so like side 1, 2, 3. Sorry guys, I'm drawing with a mouse here. Has to be congruent to the corresponding parts of these sides over here. So what I mean by corresponding, this is the smallest side and it has the three congruent marks that I drew here. So I'm going to draw the same marks here to show that they're congruent, meaning same length. Okay, this looks like the longest side here with the two marks. This looks like the longest side here with two marks. So this would be the second side, therefore it forces this one to be corresponding to the third side. So there's our three sides. We have angles as well, so maybe like angle 1, angle 2, and angle 3. So there's the other three parts that make up the triangle's six parts. Now to find corresponding positions on this triangle, I like to look at the congruence marks so that we know. Like angle 1 is between the two sides that make the angle, like with the 1 congruent mark and the 3. So the angle here between the 1 and the 3 must be angle 1. Angle 2 is between the 1 and the 2 congruent mark sides that make it, so this must be angle 2, therefore this is forced to be 3. So we would say that these two triangles are congruent if we knew that these six parts right here, corresponding parts, are congruent to each other, forces these two triangles to be congruent to themselves. So that allows us to write congruency statements, knowing it for a fact, saying maybe like if I call this triangle A, B, C, in this triangle maybe D, O. I want O to correspond to B, so I want O to be the same angle as B, right? Angle 2. And then G maybe. So we can make statements now if we prove the six parts are congruent that triangle ABC is congruent to triangle DOG, D-O-G, right? So this is what we want to say. When we have shapes that we don't really know much about them, but we can prove that they're congruent, we want to get to a statement like this. We want to prove that two triangles are congruent to each other. To do that, we got to show that the six corresponding parts are congruent to each other. But that's a lot of work. So what we have are what we call congruence theorems. Okay, they're different combinations of three parts. Right, that's just the combination, the minimum combination we need of like sides and angles in two triangles. If we know that a certain combination of these three parts are congruent in two shapes, we automatically get a know that all six parts are. So they're kind of a 3 for 6 or 6 for 3 deal, okay, in geometry. That's why we care so much about these triangle congruency theorems. So I'm going to show you what I mean by that. Let me talk about the different theorems here. Alright, now, when you look at a triangle, they have these six different parts. Three sides, side 1, side 2, side 3, and three angles. Angle 1, angle 2, angle 3. So what I mean by that is if we were to make another triangle that had these same congruent parts, like maybe this angle 3, I'm going to make another triangle that has that angle in it, and maybe this side right here, I'm going to make it have this exact same length, and maybe this angle right here. Okay, what we call that angle, or that combination of three parts, so we have an angle, a side, and an angle. Notice the side's in between the two angles, so notation-wise we call it an angle, side, angle combination. And if we're going to check to see if we knew that two shapes for sure had this combination of parts that are congruent, does that make the whole triangle itself, or the two, congruent to each other? Okay, the 3 for the price of 6, right? A different kind of combination that we could look at real quick would be like if we wanted to make another triangle that had maybe this side, and maybe this angle here that were congruent, right? So we have another triangle that has side 1, side 2, or excuse me, side 3, side 1, side 3, and angle 1, right, which we would call a side-side angle combination. Is that enough to guarantee us that we have the rest of the corresponding parts? Are they guaranteed to be congruent, therefore making the triangles congruent? So that's what we're investigating. Now, how many combinations of three parts can we make in a triangle? So like an angle, side, angle, side, maybe side, side, side. All three angles, we can call it an angle, 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 right? Angle 1. If we constructed a triangle that had the three angles being congruent, does that guarantee us congruent triangles, which we call angle, angle, angle? So actually there are 6 combinations of the three parts that we can make from a triangle. So all three angles congruent, 2 angles that are congruent in another triangle, and a side where the side is not between the 2 angles. We could also do a combination, construct a triangle that has 2 congruent angles to another, and a side that's between the 2 angles that we made congruent. Side, angle, side, 2 sides and an angle in between, what we call included in the angles, or excuse me, the sides. Side, side, angle, where we have the 2 sides but the angle is not included, not inside the 2 segments we make. And then a triangle that has the 3 sides of another one. Does that force a congruent triangle? Okay, so let's take a look at the Geogebra app now, and your job through the investigation in this activity is to check out all the 3 combinations and see which ones force congruent triangles and which ones don't. Okay, and we also have to learn how to reason that. Okay, so I'm going to show you one. I'm going to work all the way through one of these. That's the benefit of watching a video, because when you fill out your investigation sheet, you'll have the info on one of these combinations. So I'm just going to pick one. I'm going to do angle, angle, side. Angle, angle. I'm just going to write it here with the pen tool. Sorry, that looks so bad. Okay, angle, angle, side. So what that means is I'm going to grab my tool, my angle, angle, side tool. I'm just going to click on the screen here, make a triangle. Alright, so now the angles that I want to show are congruent. Then we make another triangle somewhere over here that's congruent to this one, checking to see if it's congruent based off of this combination. I mark them with a circle. So when you use a tool with this app, for some reason they don't show up right away. So if you grab your move tool and just move one of these points, change your triangle. Notice now the angle, angle, side combination is apparent. What angles are shown up are the ones that we're going to construct, and the side with a congruent mark on it is a side that we're going to construct. So we're going to construct another triangle that has the combination here that has an angle congruent to angle A, then angle C, and side CB. Now when we construct these, it doesn't really matter the order. We just have to make this combination happen. So what I would do, it's easy to make congruent segments. It's just the radius of a circle, right? So I'm going to make a circle that has a radius, the length of CB. So I'm going to grab my circle with center and radius tool. I'm going to click somewhere to start my segment that's going to be congruent to BC by making the center of a circle. And then I'm going to make a radius that's the length of CB. Click OK. Here's my circle, right? So now I just need to make a segment, or a radius. That's the whole point of the circle here. So I'm going to grab my segment tool. I'm going to click on D. That's going to be the endpoint of my segment. And then the other endpoint is just going to be some point on the circle, really. It's just a radius, right? So now we know that segment ED, no matter where it looks, is congruent to BC because we made those lengths the same. So I'm going to make ED here red, just like my segment I'm making it congruent to. And if you click this segment here down at the bottom, you can click on the scroll bar there and make your line thicker. Okay, so now we're done with this circle, so I'm going to hide it. And my conic over here, that's just a math term for conic sections. A circle is one of them. So anyways, these are your circles for now. So I'm just going to click the hide button, and now we have a segment that's congruent to segment BC. Okay? Alright, so you can grab your endpoints and move your segment around. Okay, so now what we need to construct are these two angles here. Alright, so since C is on the right side of the segment, I'm just going to make D that angle C here. Okay, so what I'm going to do, I'm going to go through the construction of a congruent angle pretty quick, I think, through the video. If you're lost on this, make sure you go back and watch my tutorial on how to construct congruent angles, also congruent segments. Okay, so I'm going to grab my circle with center through point tool. I'm going to make my isosceles triangle by making C my center of a circle and putting a point on one of the segments. That segment CF right now is going to be the radius of my congruent circle over here. I'm going to go ahead and make my base of my isosceles triangle with my segment tool right now so that I have my other radius so I can make my angle real quick. So I'm going to click on this intersection point, which it makes the intersection, and then point F here, my two intersections of the circle and my triangle, to make my base of my isosceles triangle, which will be reconstructed over here with circles. So now we're going to make congruent circles. I'm going to grab my circle with center and radius tool, since I know the radius of my circle I want to make. D is going to be the center of my circle, and now I'm going to make a radius of segment CF. Click OK. Now I have two congruent circles here. Now this intersection point is the same as this point here. So now I'm going to make another circle with this radius FG centered at this intersection so I can make this base. So I'm going to grab my circle tool, which I already have. I'm going to click on that intersection, ask for the radius. It's FG on my construction. Make sure that you check your labels. They may not be the same as mine. Okay, so now this point right here, this intersection, is like this point F on my triangle. So what I have made here is, if I were to connect these 3 points with segments, it's a congruent isosceles triangle as this isosceles triangle that we made. So my angle is really going from D through this point and in that direction. That's going to be congruent to this angle here. So now I'm going to grab my ray tool to finish off my angle. I can't grab a segment tool really because I don't know the length of segment AC. I'm not going to construct this to be congruent because that's not our combination that we're making. So when we do an angle next to an angle, that's kind of tricky. What we're going to do is, and let me finish off this angle here, I'm going to, with my ray tool, I'm going to start at a point D, and then I'm going to go through that intersection I. So no matter what this triangle looks like, that angle that I constructed is going to be congruent to this angle C here. Okay, so now let's go ahead and hide our circles. And I'm going to make this ray blue because it's really like the blue side of my triangle that I'm making here. Okay, so now this second angle that we got to make, we don't know where to put the vertex, right? That third point of the triangle really on the ray to make this triangle here. Right now, it's kind of looking like we're going to get congruent triangles, right? These are pretty much the same thing. If I were to rotate B to map onto E, right? A would probably map onto this ray. Not even probably, it will. It looks like. Let's try that. Let's see. Oh, there we go. So right now we have congruent triangles. You know, I wonder if this combination, this angle, this side, this angle here, and then this other angle makes the congruent triangle. So we need to just start our third vertex, our angle of our third or excuse me, the vertex of our third angle anywhere we want on this ray. That's kind of the point of a ray. It goes off forever, so it doesn't matter where we put a point on it. So I'm going to grab my point tool. I'm going to put a vertex point on my ray here. So now this blue side is this side of the angle that I'm going to construct. So I got my starting side. Okay, so now I'm going to make my isosceles triangle. So I'm going to grab my circle tool, put a point on the side there. So now I have my radius AK in my construction. I'm going to go ahead and make my base of my isosceles triangle so I know my second radius. Okay, so now I'm going to grab my circle with center and radius tool. I'm going to make this point J that I put on my new ray down here my center point. And I'm going to make a circle with radius AK. Alright, so here's AK. Congruent circle there. Now, at one of these intersections, probably I would imagine this one, it looks like where K is here. I'm going to use this one here. I'm going to click at that intersection point on my circle and my ray, and I'm going to make this circle with my base of my triangle as my radius, which is LK. So I'm going to put LK in the radius bar here, click OK. There's my triangle. So now this intersection point of our two circles is just like this point here. So we actually made a congruent isosceles triangle as this one here. Therefore, the angle finalized with a ray starting at J going through this point here, my point N, creates a congruent angle. No matter what this triangle looks like, it's going to stay congruent. Alright, so now the question is, you know, this combination angle side, we have a congruent angle here, right? Angle NJM here is congruent to this angle. Let me show its label, 95 and 95 on mine. And then this angle here, so I'm going to right click it and show its label. That color is hard to see probably in this video, so I'm going to make it darker. So this angle here is 50 degrees, and if I measure this angle here, I bet you it's 50 degrees. Okay, so now we have these two shapes here. One's a triangle, one looks like a triangle, but now if I move J, the vertex of this angle, see, we don't really know the length of this side yet, but all we had to construct was a congruent segment and two angles. So we don't, the point of this is that when this ray goes off in the angle and it contains the other vertex now at this situation right now, is this triangle the exact same as this triangle? So to check it real quick, we are going to check this angle and make sure it's the same measure as this angle. So I'm going to click on D, E, J. Notice this angle right now is 35 degrees. So if these are congruent, this would be 35 as well. So I'm going to click on E, B, A, and notice it's also 35. So the three angles themselves are congruent to these three. So we got 3 of the 6 parts. We know that we constructed this red segment to be congruent to this red segment. So we know that one of the 3 sides, corresponding sides, are congruent. So all we have to check to make sure these 2 triangles are congruent real quick is this blue segment congruent to this blue segment here, and this side here is congruent to this green side here. So let's just use our measurement tool real quick. So in this toolbox, it's the one next to the sliders here. Where the angle tool, thank you. The angle tool has our measurement tools in it. I'm going to click distance or length. Okay, so what I'm going to do is just check real quick. I'm going to check the distance between point AC. So right now that's 5. I'm going to check the distance between DJ, this other side, and notice those are 5. So 2 pairs of sides are congruent. This third side, I bet, is congruent to this side here. So I'm going to measure this side AB by clicking on point A, then point B. It has a length of 7, and then J to E, it has a length of 7. So therefore, these 2 triangles are congruent when we construct 2 triangles that have a side, an angle, and an angle congruent, right? So even as we move the original, right, notice these now are congruent no matter what. So what we mean by forced to make congruent, this side length, we didn't even construct, we didn't even measure. We didn't even measure this one, just we made the angle hit this point, which forced these segments to be congruent to these segments over here. So that's what we mean by congruence. So this would be an example of a picture to draw on your notes. Draw these triangles, mark their sides and their angles to show, and then also mark, the congruent mark. So, draw your shape here so that this has a congruent mark to this one. Maybe this one's congruent to this one. This one's congruent to this one, right? So draw that in your notes and then move on to the next one. You don't have to save the file. You can just move on, do File New, and get yourself a new one. Alright, so that's how we use, that is triangle construction, or congruence, and how we use the congruence tools. Good luck.